Welcome. Today we're going to look through some of Test 3 to answer some of the questions involving stoichiometry and thermochemistry. In this special video, we're going to go through Test 3 and work out all the problems. In the following reaction, zinc and HCl react to form hydrogen gas and zinc chloride. How many grams of zinc are required to react with 0.672 moles of HCl? As it is, that's not a bad problem. So we turn moles of HCl to moles of zinc to grams of zinc. We'll need to know the molar mass of zinc and look at the balanced chemical equation. I think the molar mass of zinc is 65. It's 65.4. Looking at that, 672. 672 moles of HCl. For every 2 moles of HCl, we need 1 mole of zinc. And for every 1 mole of zinc, it weighs 65.4 grams. So 0.672 divided by 2 times 65.4. You'd get 22 grams. You round up to 22 grams. So the correct answer is B. And down. A piston in a particular system undergoes compression, thus absorbing 230 joules of work upon a compression. The gas then releases 315 joules in the form of heat. What is the internal energy? So the internal energy, delta U, is equal to heat plus work. In this problem, you're given both heat, you're given both and work. So you figure out the sign, sum them up, and find the internal energy. So absorbing work means work enters. So a positive 230 joules of work. It releases heat. So it's a negative 315 joules of heat. Negative plus a positive is going to mean this is going to be negative 85 joules, or D. Okay. If 50 grams of each reactant are present, what is the maximum amount of sodium chloride that can be formed? Straight up, this problem is a limiting reagent problem. How do I know? Because I'm giving a mass of 2 separate reactants. And my keyword maximum amount, don't let that fool you. We will choose the amount that forms the least amount of sodium chloride. Least amount of sodium chloride, because that is made by the limiting reagent. So I'm going to turn 50 grams of sodium to sodium chloride and 50 grams of chlorine to sodium chloride, and we'll see. 50 grams of sodium. Sodium is 23 grams in 1 mole. For every 2 moles of sodium, there's 2 moles of sodium chloride. And the molar mass is, molar mass is 23 plus 35.45, so 58.45. Now doing the other one, setting them up, 50 grams. The molar mass is 70.9 because 35.45 times 2. For every 1 mole of chlorine, we will have 2 moles of sodium chloride. And the molar mass is the same. Okay. Where does this equation differ? It differs right there and right there, the molar mass. So one we have divided by 23 times 2, which is 46. The other one is divided by 70.9 times 1, which is 70.9. So if I work this out, if all of the sodium were to react, we could get 127 grams. But if all of the chlorine were to react, we could only get 82 grams. So with that in mind, we choose the lesser of the two numbers. So the correct answer is 82 grams. When a 7-gram sample of potassium nitrate dissolves in 100 grams of water, the temperature of water decreases by 5.78 Kelvin. What is the delta H of solvation if the heat capacity of water is 4.184 joules per gram Kelvin? So this is broken into 2 parts. Q equals MCAT, and Q, then we have to turn Q into delta H solvation. So the water decreases. So Q equals MC delta T, and then delta H solvation is equal to negative Q divided by the moles. Now, the way I think I set it up is just 100 times 4.184 times a negative 5.78. So, but if you added the 7 grams in there, you'd probably still get a similar number. So I'll add the 7 grams in there. 107 times 4.184 times negative 5.78. My Q, 7 times 4.184 times negative 5.78 be negative 2587.6 joules. Now, how many moles is 7 grams? How many moles is 7 grams? 7 grams are, and so the molar mass of potassium, 39.1 plus 14 plus 16 times 3. So the molar mass of potassium nitrate is 101.1. So 7 grams divided by 101.1 grams and 1 mole would give us, that's 0.0692 moles. So what I'm going to do, I got to flip the sign, so positive 2587.6 joules divided by my 0.0692 moles, and of course turn this into kilojoules, because what are the units I give you here? Kilojoules. So 258.6.069. So now Yeah, so that's the question. So I got 37. Now, I'm guessing that's because I did it 100 grams instead of 107. So either way, this number A is what I was going for. C would have been if you had just solved the Q equals MCAT. 8 divided by. Yeah. So making it 107 instead of 100 changes it just a bit, just a teeny bit. But either way. Continuing on. Calorimeter problem. I'll go ahead and include this one because it helps remind us of how to do Q equals MCAT. During lab, a reaction between 50 mils of 2 molar ammonia and 50 mils of 1 molar HCl, creating a total mass of 100 grams solution, was mixed together, at which point the temperature of solution goes from 25 degrees to 62 degrees. If the water has a specific heat of 4.184, the calorimeter has a specific heat of 39.5, what is the heat absorbed by the calorimeter and the solution in kilojoules? So first things first, what is our delta T? 62 minus 25 is positive 37. 37. So the solution is going to be Q equals MC delta T. So it's going to be 100 times 4.184 times 37 divided by 1,000 to get this into kilojoules. So you'd get 15 kilojoules. I would say 15.5. 15.5 kilojoules for that. For the calorimeter, it's just going to be Q is equal to C cal times delta T, or divided by 1,000, which is going to be 39.5. 0.5 times 37 all over 1,000. And so you would get what, like 1.46 kilojoules. So those would be the answers for problem 5. Problem 6, okay, based on that, what are your total heat of based on your total heat of surroundings from problem 5, what is your heat of reaction? So problem 5, we have to add those previous two parts together to get the total heat, which would be 16.9. 16.9. 16.9, would have to flip the sign and then would have to divide by the moles. Well, we have 1 molar HCl and we had 0.05 liters. So how many moles did we have? Would have 0.05 moles. So we use 16.9 divided by 0.05. You get negative 338.8. Negative 338.8. Okay, problem 7. Problem 7, pretty standard. What is the molarity of this solution if I use this many grams? So we're going to turn grams to moles to molarity. We need potassium, we need bromine to do this. Potassium, we need bromine. Potassium is 39.1. Bromine is 79.9. 9 plus 39.1. Molar mass of 119. So 35 grams divided by the molar mass, which is 119 grams per 1 mole. And we have to divide by my volume in liters. Divided by 0.080 liters. Because we're looking at moles over liters. You would get 3.67, which rounds up to 3.7, or C. Calculate the delta H of this one. Pretty straightforward, pretty standard. Look at what we need, add up all the products, add up all the reactants, subtract. Delta H reaction is the sum of all the products minus the sum of all the reactants. So for all the products, we have acetic acid of negative 484.3. We have 2 silvers, which is 0 times 2. And we have 1 water, which is negative 285.83. So on the product side, we have a total of negative 770.13. On the reactant side, we have ethanol, essentially aldehyde of negative 166.2. We have 2 silvers, which is positive 105.8 times 2, and 2 hydroxides, which is negative 230 times 2. Got to remember, you have to take into account the coefficients. 230 times 2, 5.8 times 2, plus 166.2. Okay. So you get negative 414.6. Basically, what we're doing here, products minus reactants. So negative 770 minus negative 414. You would get negative 355.5, which rounds to negative 356. So B. Cobalt ore, or scutterudite, can be processed the following way. Taking the cobalt arsenic compound, the scutterudite, and oxygen, you can produce pure cobalt and some arsenate compound. Diarsenic trioxide. Now this one, if 585 grams of scutterudite is processed to form 102 grams of cobalt, what is the percent yield of cobalt? Or what is the efficiency? It's a percent yield problem. So we have to turn cobalt arsenic into cobalt and to figure out the theoretical yield. So starting with 585 grams. What is the molar mass? This is a little hard one because we have 2 compounds we don't usually use. Cobalt is 58.9 and arsenic is 74.9. And there's 3 arsenics. So the molar mass of this guy is 283.6. 283.6 1 mole. For every 4 moles, you get 4 moles. And as we said, cobalt is 58.9. Cobalt is 58.9 grams per 1 mole. So 585 divided by 283.6 times 58.9 gives us how much could we form? If in perfect world, we could form 121.5. Now we actually formed 102. So 102 divided by 121 times 100 will give you 84%. Quick fix. Having over 100% yield should not happen unless you really screwed up. Water-gas shift reaction. Carbon monoxide can be used to form hydrogen gas from steam by burning coal. Can conveniently form carbon monoxide from... So, okay. If we have 350 kilograms of carbon, it burned, how many moles of hydrogen could be formed? So literally we are turning kilograms to grams to moles of carbon to moles of hydrogen. So I'm not even going to work this out. 350,000 grams would divide by the molar mass of carbon, which is 12. Then for every, that'd give you 29,166 moles of carbon. For every 1 mole of carbon, you produce 2 moles of hydrogen. So I multiply by 2, I'll get 58,333, which rounds to 58,300. The big thing that tripped people up would be kilograms. Standard enthalpy of hydrogen gas. How am I supposed to know that? It's 0. It's always 0 for an element in the standard state. Hess's law problem based on this. Based on these reactions, how much energy would this reaction form? The iron and carbon goes to iron, iron oxide and carbon goes to iron and carbon. So, looking at this reaction is correct as is, but it's backwards. So we would have to flip that. The carbon needs to be tripled, but it's going the correct direction. So what does that mean? In order to get the reaction that we want, we need 2 iron oxides as a reactant, and this one has 2 iron oxides as a product. So we would flip that one. So we get 1648.4. It's positive. This one has 3 carbons as a reactant, and this one has 1 carbon as a reactant. 3 carbon dioxide as a product, 1 carbon dioxide as a product. So we need to triple that whole reaction. So we'd get negative 393.5 times 3. We do that. 5. You get negative 1180.5, 1648.4. You would get this reaction costs 468 kilojoules. Reaction costs 468 kilojoules to do. Bismuth has a specific heat capacity of 0.12. What is the final temperature of bismuth if 215 joules of heat are transferred into 75 grams of bismuth at initially 20 degrees C? So this is a Q equals MCAT where we're solving for delta T. So Q equals MC delta T. We have 215. So 75 times 0.12 times T final minus 20. If we want to set up the whole thing. But really, we want to find delta T. First, we want to find delta T. So 215 divided by 75 divided by 0.12 says our change in temperature is 23, almost 24 degrees. Now, the answer isn't 24 because that is the change in temperature. And I asked for what is the final temperature. So I have to add 20 degrees onto it. So if I started at 20 and went up 24, the answer would be 44, or B. 14 and 15 are related. In a titration between 0.23 molar and a 25 of KOH and 25 mils of acid, the burette base went from 5.03 mils to 42.01 mils. Reach endpoint. What is the concentration of acid? So we have to figure out what volume of base I added. 42.01 is my stopping point, and 503 is my starting point. So I've added 36.98 mils of base, and I have a concentration of base. And so the question is, how much? So the question is, what is our molarity? 23 times 36.98 equals 25 times molarity. Do that real quick, times 0.23 divided by 25. You would have a molarity of 0.34. M of acid is 0.34 molar. So that's 14. 15. If the acid from question 14 was made by diluted 5 mils into 100, what is the original concentration? Just like in lab. So if that's our dilute, the dilute is in a 100 mil solution. 5 times M. So we're going to times by 100, divide by 5, and it went up by a factor of 20. So the original concentration is 6.8, which is pretty concentrated. Okay. 16. In a 100 ml solution of 18 molar sulfuric acid, how many grams of sulfuric acid must be present? So in this case, I'm turning molarity to moles to grams. So 18 times 0.1 would give us 1.8 moles. My molarity, so sulfur is 32, 2 hydrogens plus 16 times 4 would give us molar mass of 98 grams in a mole. So 98 times 1.8 means you would have 176 grams of sulfuric acid in that 100 mils of water. Almost done. Last 2 or so. Maybe a few more. I don't know. Okay, elephant toothpaste reaction. Hydrogen peroxide produces a large amount of gas and bubbles as hydrogen peroxide decomposes to water and oxygen. If 3 moles of hydrogen peroxide were to decompose, how much energy would be released? Okay, this one was a tricky one. This is much trickier than I'm asking of you guys. Because based on the chemical reaction, how much energy is released in this given chemical reaction? We'd have negative 285.83 times 2 minus negative 187.8 times 2. So, to do this reaction one time, 285.83, times 2 minus 187.8 would produce 196 kilojoules. That's per 2 moles of peroxide. If we were to react 3 moles of peroxide, it would be 1.5 times, or 3 over 2 times. So the correct answer is actually 294. As I said, that was a tricky one. A lot of people chose 196 because they did not read that. I've asked more problems, so I've asked less hard problems. Titration of 0.8 molar acetic acid in baking soda requires 43 mils of acid to completely react with 75 ml baking soda solution. What is the concentration of the baking soda? So 0.8 times 0.43 divided by my 75. Once again, this is the MAVA equals MBVB. So you would get the baking soda solution is 0.46. Or B. Last two. Okay. Diethyl zinc and air combust violently to form zinc oxide, water, and carbon dioxide. If you expose 320 grams of diethyl zinc to air, how many grams of zinc oxide could you form? So, grams to grams. Grams to moles to grams. So 320. That's my starting number. Zinc is 65.4. Carbon is 12. There's 4 carbons. Hydrogen is 1. There's 10 hydrogens. So the molar mass of diethyl zinc is 123.4. There's 1 for every mole of diethyl zinc, we get 1 mole of zinc oxide. And the molar mass of zinc oxide, 65 plus 16, is 81.4. So 320 divided by 123.4 times 81.4, 211 is your answer. So D. And finally, another impressively explosive reaction is cesium and water. The delta H, what is the delta H of this? So it's literally hydrogen. There's a reason. This is 0. This is 0. But we just have to calculate, well, negative 477.7 times 2 minus a negative 285.83 times 2. So how much energy does this produce? It's negative 384. Negative 384. And that, my friends, was the end of this test. So they were given the periodic table. They were given conversion of Celsius to Kelvin, percent by mass, how to get moles, how to get molar mass, Q equals MCAT, delta H reaction, the internal energy, grams to moles grams, percent yield, M1, V1, in all its glory. Q system equals negative Q surroundings, and how to get delta H reaction. Okay. So that is all we have on that test.